If you watched our previous video about writing the equation of a circle centered at a point, this is going to be a very similar process. The difference is, while I do know where the center of the circle is this time, I don't know the radius. Rather, they give me another point on the circle. So let's begin the same way. I know kind of the outline of my equation is going to be a set of parentheses with x and then a number squared, plus a set of parentheses with y and a number squared, and then equal to something else. I can go ahead and fill out the center right away. I know that these two blanks are going to be made up of my center points. Now, it's very important that we look at the right point, the right coordinate. So there's where the center is located. I remember that I take the opposite of both of those numbers. So the opposite is going to be an x plus 1 for the first blank, and then a y minus 3 for the second blank. Now, to figure out the radius, I'm going to need to do a little bit of work. And there's a couple ways we could do this. We can do this by making a sketch, or we can use the distance formula. I guess I'll show you both in this video. I'm going to start with making a sketch. So if you have a piece of graph paper, actually, if you have graph paper, it's even easier to do because we're going to end up doing some counting on our sketch. Otherwise, I'll just draw a sketch on the side real quick. And so there's a sketch of what I'm looking at. So what we need to do is we need to figure out how long this radius is from the center point to that point on the circle. Well, I'm not allowed to count diagonally, but here's what I can do. I can count vertically, and so what I'm going to do is draw a vertical line down from that point. And depending on the accuracy of your sketch and how easy it is to see, I can see that has a length of 3 spaces. If I were to count horizontally as well, I'm allowed to do that. Again, depending on the accuracy of your sketch, I can see that has a distance of 4. And so seeing the problem drawn this way helps me realize, oh, to find the radius, all I'm going to do is Pythagorean theorem. And so the two legs of my right triangle are 3 squared plus 4 squared, and that's equal to the radius squared. Doing a little bit of algebra, if you don't know this triple already, I end up with 9 plus 16 is the radius squared. So 25 is equal to the radius squared, which actually I can stop right there, and I'll explain why in a second. If I went all the way, though, I'd find out that the radius is 5. Well, even though the radius is 5, remember that what I need for the blank over here is I need the radius squared. And so 25 is going to be the number that finishes out my equation. So here is the equation of the circle that would be centered at the point -1, 3, and have a radius that would get us the circle going through this point. Let me show you another way to do this problem besides just sketching it, or if you don't want to sketch it, sometimes you have difficult numbers to use. Let me show you how we can find that same value using the distance formula. So recall that the distance formula was the square root of x1 minus x2. So in this case, I'm going to go -5 minus -1 squared. It's really the same thing as Pythagorean theorem, plus y1 minus y2 squared, so 6 minus 3 squared. Okay, and you can go back and watch an old video if you want help with the the distance formula. So I end up with then the square root of, I'll do that to make that a -4 squared plus 3 squared. Do these numbers look familiar to you? Squaring -4 in parentheses means I'm going to get a positive 16 and then plus 9. Look, there's the numbers we saw before. Oops, I'll throw some equal signs in there, which equals the square root of 25, which again gets me a distance of 5. Well, make sure that you understand that this number, remember, is the radius of the circle, and in the equation I need the radius squared. That's again why we had a 25 up there. So there's 2 different ways you can find the radius of the circle. One way by making a sketch and doing the Pythagorean theorem, or by using the distance formula.